Today, we are pulling back the curtain on a process that's absolutely vital to modern medicine, but one that most of us, thankfully, never get to see. We're going to follow the secret journey of a biopsy after it leaves the patient.
You know, a lot of us have had a mole removed, or maybe a small tissue sample taken for a test. It just disappears behind a closed door, right? And then a week or so later, you get a call with the results. But that whole journey in between, well, it's this incredibly precise, high-stakes process. So what really happens to that piece of you?
Okay, so let's get right into it. The whole chain of events kicks off the very second that sample is collected. This first step is all about identity and information, and trust me, getting it right is everything.
See, no tissue sample ever travels alone. It gets immediately paired up with a request form. The best way to think about this is like the sample's passport. It's its ID, its travel itinerary, everything, all rolled into one. This one piece of paper connects that very specific piece of tissue back to a very specific person.
And the information on that passport, it has to be absolutely perfect. We're talking correct patient ID, the exact date, a clear clinical history, what kind of tissue it is, you name it. A tiny error here, any little mix-up, could have devastating consequences later on. There is literally zero room for error. So, once the sample is logged in the lab, checked and double-checked, it's time for its first real examination. And this next step is called grossing.
I know, the name sounds a little weird, right? But grossing just refers to what you can see with the naked eye, the gross anatomy. This is a huge decision-making point in the journey. A pathologist looks at the tissue and has to decide which specific areas are the most important, the most telling, for what comes next. And this is what I find so fascinating. This step is way more than just a science. It's a real art form. In a world where so much is automated, this part relies on incredible human skill. It's about experience, about having a trained eye that can look at a piece of tissue and know, okay, that little section right there, that's the part that's going to tell us the whole story. The final diagnosis literally depends on this choice. And it is a very hands-on process. You can see the whole toolkit here. Rulers for measuring, scalpels for soft tissue, even tiny saws if it's a bone sample. They take detailed notes, and then the most important sections get carefully cut and placed into these little labeled plastic cassettes to continue their journey. Okay, so the key pieces of tissue have been selected. Now the race against decay really begins. The sample has to be perfectly preserved, and this next phase is a chemical journey designed to basically stop time at a cellular level. The first, and maybe the most important chemical step is called fixation. The whole goal here is to just lock the cells in place, in as lifelike a state as possible so they don't start to break down. You can kind of think of it like pickling vegetables. A chemical, usually formalin, is used to just stop all biological activity cold. Without this, the sample would just fall apart and a diagnosis would be impossible. Next up, you have to get all the water out of the tissue. This is called dehydration. Now, why do that? Well, it's because the sample is eventually going to be put into paraffin wax. And as we all know, wax and water, they do not mix. So to get around this, the tissue takes a bath in a series of alcohol solutions, each one a little stronger, that gently pulls out every last drop of water. But here's the thing, alcohol and wax don't really mix well either. So you need a middleman, and that step is called clearing. A chemical like xylene comes in and replaces all the alcohol. Now this new chemical can mix with wax, so it acts like a bridge, getting the tissue ready for the next step. Now, this whole chemical dance, the fixation, the dehydration, the clearing, it's usually automated. The little cassettes with the tissue inside are placed into machines like this, called tissue processors, and the machine just methodically moves them from one chemical bath to the next. It's a super precise process that often runs all night long. All right, so after its overnight chemical spa treatment, the tissue is perfectly preserved and prepped. Now it's ready for a big physical transformation, one that's going to make it possible to do the final, most delicate steps. This is where infiltration and embedding come in. First, the tissue gets soaked in hot molten paraffin wax, which seeps into every single nook and cranny of every cell. Then it's placed in a small mold, filled with more wax and left to cool. What you end up with is a solid block of wax with the tissue perfectly protected inside. This gives that soft, fragile tissue the solid support it needs for what's coming next. And you can see here, this is very careful manual work. A technician puts Wattwalks in a mold, uses forceps to orient the tissue just right, puts the original ID cassette on top, and then fills her up with more wax. Then it's off to a cold plate to harden into a solid, stable block.
So we have our tissue, safe and sound, inside a solid wax block. This brings us to the climax of the entire journey, the stage where that block gets turned into a glass slide that a pathologist can actually read.
And this amazing step is called microtomy. It is the art and science of cutting unbelievably thin sections from that wax block. I mean, the level of precision we're talking about here is it's truly mind-boggled.
And this is the machine that makes it all possible, the rotary microtome. Honestly, the best way to think about it is like a super precise deli slicer. The block moves up and down against an incredibly sharp blade, shaving off a delicate ribbon of wax sections. Each one is just 4 or 5 micrometers thick. That is way thinner than a single human hair.
Now those sections are so delicate that they're often wrinkled. So to fix that, they're gently floated on the surface of a warm water bath. This lets them relax and flatten out perfectly. Then, a technician has to skillfully scoop up a single flawless section onto a glass microscope slide. It takes a really steady hand. But we are not quite done yet, because right now the tissue on the slide is still totally transparent. To actually see the cells, it has to be stained. The slide is run through an autostainer, which uses a sequence of dyes. Most of the time, it's hematoxylin and eosin, which dye the cell nucleus purple and the cytoplasm pink. This is the final touch that makes the invisible visible.
And this is the final product, the end of this incredible hidden journey. What started as a simple piece of tissue from a patient is now a permanent record, a perfectly preserved, stained slice on a glass slide ready for the pathologist's expert eye and finally, a diagnosis.
Just think about that for a second. All of that meticulous science, that hands-on art, that complex chemistry and delicate precision, all of it just to create one single fragile slide of glass, a slide that holds an answer. And for a patient somewhere, that answer can mean everything.